Alright guys, so in this example, we're going to do another example of a Newton's second law problem to try to help solidify our understanding of this. So it says, a rightward force of 100 newtons is applied to a 5 kilogram object to accelerate it to the right at 10 meters per second squared. And it says complete the diagram. So this is kind of like the ones we saw in the worksheet we did in class, and also in some of the problems we did, like the exit ticket. Okay, so think about what we're given here. We are already told there's a rightward force of 100 newtons, so we're going to put that in the diagram. And I'll call that just applied force. Okay, but think about what other forces are acting here. Obviously, gravity is going to act on an object, so we're going to put that in. And remember, to calculate a force of gravity, which we call weight, we do the mass times g. G is 9.8 on Earth. So the mass, 5 kilograms, times 9.8. If I do that, I get that the force of gravity is 49 newtons. That's what I know so far. That's what's given. They also tell us that the acceleration is 10 meters per second squared, and it's to the right. That's important. Okay? So think about that being, it's to the right. All right? So we need to make sure we finish this diagram before we try to go through the rest of the steps. So let's think about what's going on here. All right? If the object's accelerating to the right, it's not accelerating up or down at all, then there's got to be an upwards force here. Because if there wasn't, think about it. If gravity was pulling down on this object and there was nothing supporting it, it would be falling. And that's not what's happening here. So there's definitely an upwards normal force. So I'll put an N for normal force. Okay. And there is also friction in this situation. So let's draw that in. Like this. Okay. Now, let's follow the second step here. It says write out Newton's second law in each direction. Now I'm going to start with the y direction, which is the vertical direction. And most of you might already know how to figure this out, but I'm going to write it out step by step anyway. So Newton's second law is right here. Mass times acceleration equals net force. But watch what I do here. I'm going to write the mass times the acceleration. And I'm going to put a little subscript y here for the y direction. Think about in math. In the y direction, we mean vertically, up or down. And then net force. And I'm going to put another y for the y direction. Okay? So that's Newton's second law. That's step 2. We're done. Okay? All right. Now it says list the forces. I know it's a little hard to see here with the reflection. But it says list forces. So when you see this symbol here for net force, what I want you to think about is listing all the forces in that direction, in the y direction in this case, so vertically. All right, so let's write down all the vertical forces. Well, we have this one, the N, and we have this 49 also. But they're in opposite directions. So I'm going to write them like this. If they were in the same direction, I'd put a plus between them, but they're opposites. So I'll put a minus. Okay, now, the mass is 5 kilograms. They tell us that up here. This stands for the acceleration in the y direction. That means the vertical acceleration. Well, it's not accelerating vertically. It says accelerating to the right. The acceleration in the vertical direction is 0. So if we do N, that's the normal force, minus 49 newtons, we have to get 0. So what does that tell me? That tells me the normal force must also be 49 newtons. And if you think about it, that makes almost obvious sense, right? These two forces have to balance out if it's not accelerating up or down. All right? So we could take a look at what I did there in the y direction. I'm going to use the same exact type of system to do the horizontal forces now, the X forces. So let me erase what we have here at the bottom, and we'll do the same exact thing for X. Write out Newton's second law. So ma, but I'm going to put an X this time. And I'm going to put net force in the X direction. Okay, again, let's list the forces, but this time horizontal only. We don't want to mix up vertical and horizontal. They're two separate directions. So we have this 100 Newton force, and we have this friction force, which we don't know how big it is. Let's just do minus FF for now, right? Because they're in opposite directions. Again, if they were in the same direction, I'd add. Okay. On the left-hand side, I have the mass times the acceleration in the X direction. Well, the mass is 5 kilograms. The acceleration is 10 meters per second in the X direction because it's to the right. So 5 kilograms times 10 meters per second squared, 50 newtons. That is the net force, 50 newtons, because that's the mass times the acceleration. So if I have a question of what's the net force, it's 50 newtons. Okay? Now, the last step. Let's find what this frictional force is. I think you could figure it out pretty easily, even without a calculator. We have 100 newtons to the right. We have some unknown amount of force to the left, but the two of them combine to give us 50 newtons. So that tells me, well, that friction force must be 50. And I can put that here. All right, and we already figured out, I didn't write it here, but the normal force was 49. Okay, so if you follow this process every single time, you'll be able to solve any problem that you're going to be asked. Okay, so you want to start out by making sure your diagram is correct, using the mass to find the weight, or vice versa. If you know the weight, you can find the mass. Okay. You want to write out Newton's second law in the y direction and in the x direction. Right now, I only have the x written down because of the space on the board, but we did the y direction earlier. Then you do the x direction. All right. And then you want to solve for whatever things are unknown that you're trying to figure out, and just break it down step by step.